Now, there are a few alternate forms of the derivative that we want to go over because sometimes one will be a little bit easier to use than others. All right, so the first one we've actually kind of already used, and that's by saying that f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Now, technically, this is an alternate form because it's not using the delta x that is technically supposed to be there, okay? But this, again, gives you the slope of the tangent line for any point or x value. Okay. Another form that is equally useful is f prime of a specific number c, and that's equal to the limit as x approaches c of f of x minus f of c all over x minus c, which looks more like our slope formula, okay? Now, why would we want to use this? Well, this is used to find the slope of the tangent line at x equals c, meaning at a specific point. Now, this secondary rule here, this secondary form in green, actually comes in really handy when we're trying to find the slope at a particular point because there's a little bit less algebra involved in most cases, all right? So some additional notation that we need to understand for a derivative. We've been talking about f prime, f prime, f prime, but we know not all functions are listed as f of x, okay? So we can see y prime. If we see a y equals, then we'll see y prime. Or we could see dy dx, which means the derivative of y with respect to x being the variable in the function. We could also, similar to dy dx, we could see df dx for f prime of x. Instead of writing f prime of x, I could write df dx. Or if it was g of x equals, I could see dg dx. I think you guys kind of get the drift here, okay? This dy dx notation comes in really handy when we're doing other types of derivatives down the road, so it's something we want to get familiar with now, okay? But let's take a look back at this green alternate form of the derivative and see it in action. All right, so problem number 3, here we go. We want to find g prime of negative 3 using this particular quadratic function, okay? So we're going to do g prime of negative 3 is equal to a limit. This time as x approaches negative 3 of g of x minus g of negative 3 all over x minus negative 3, okay? So what that means we're looking at here is the limit as x approaches negative 3 of g of x is x squared plus 2x plus 1 minus g of negative 3. Negative 3 squared is 9, plus 2 times negative 3 is minus 6, plus 1, all over x minus negative 3 is really just x plus 3. Okay, so again, this came from finding negative 3 squared plus 2 times negative 3 plus 1. So that was the direct substitution for g of negative 3. So what I really have in the parentheses there, let's see, 9 minus 6 is 3, plus 1 is 4. So I'm looking at the limit as x approaches negative 3 of x squared plus 2x plus 1 minus 4 all over x plus 3. All right, but that really is the limit as x approaches negative 3 of just x squared plus 2x minus 3, which becomes a factorable quadratic equation in the numerator. And the nice thing about using this alternate definition is I'm guaranteed to be able to reduce the factor in the denominator out. So this is really the limit as x approaches negative 3 of x plus 3 times x minus 1 all over x plus 3. So that gives me the limit as x approaches negative 3 of x minus 1. which is really just negative 3 minus 1. Final answer is negative 4. Okay, so that's what g prime of negative 3 comes up to. All right, so that means the slope of the tangent line at x equals negative 3 comes out to negative 4. Now, again, this is still a very long and involved process, but usually the algebra is a little bit easier than doing the binomial expansion theorem. So this comes in really handy, especially if you have a higher order polynomial instead of just a quadratic. All right.